all of this, my other phone is complaining about something. All of this can kind of be explained with classical mechanics, and NASA still uses classical mechanics to launch rockets. Okay, so what is this? Oh, there it is. My phone has resurrected itself on Easter. Well, not really Easter, post-Easter. It had died, as in its battery was completely off. And so as I turn it on to share the live, it's doing many, many things right now. Did you share the live? That's what mods are for. Thank you, Chickpea Break. Thank you so much. Okay, let me share it. So because we live in this classical mechanics related world, classical mechanics explainable scales and world, we do not have a developed intuition for, I asked because it's only me here. I see a few more people, as in I see a few people on the live. Maybe I'm wrong. And you know, that's okay. Only you is also fine. We can have a party of two. We can just chit-chat, you know? Yeah, they now arrived. Okay. Hello. Okay. So we don't really have an intuition that's super informed for special relativity because we don't live in scales that are generally relevant to special relativity. Okay? All right. So in short, the solution is that our intuition is wrong. It is informed by motion that typically is extremely slow compared to the speed of light, and such low speeds obscure the true character of space and time. So the way we experience space and time is quite different than the one that would be sort of relevant or implied in special relativity. Special relativity reveals their nature and shows them to differ radically from previous conceptions. Tinkering with our understanding of the foundations of space and time, though, was no small undertaking. So giving us sort of this deeper insight into space and time, and giving us really what the speed of light being a constant of nature meant, and what that means for light as a wave, and all of that stuff that special relativity really gave us, was no mean task. Hello, V. V says, V, I'm the real one. Hi. Hello, V. So, tinkering with our understanding of the foundations of space and time, though, was no small undertaking. Einstein soon realized that of the numerous reverberations following from the revelations of special relativity, one was especially profound. Thank you. Thank you for the comments. The dictum that nothing can outrun light proves to be incompatible with Newton's revered universal theory of gravity proposed in the latter half of the 17th century. So again, this is another way of saying that the speed of light in vacuum is a constant of nature and nothing can really surpass it. And so while resolving one conflict, special relativity gave rise to another. After a decade of intense, sometimes tormented study, Einstein once again revolutionized our understanding of space and time by showing that they warp and distort to communicate the force of gravity. Because remember, special relativity did not really give us an explanation for gravitation. Special relativity works for inertial frames of reference, as in things that are going in a constant speed or at rest, right? Because that's also a constant speed. So it's sort of an explanation of how light works, how E&M works, electricity and magnetism, wave nature of light, and sort of the relative nature of space and time. That is special relativity. But if you have to understand accelerating frames, if you have to understand gravitation, then you needed to do more work, which he did. He spent more years working on the next theory, which was the general theory of relativity, which really gives us the more general theory versus the special case of relativity, which is the special theory of relativity. So this is where we will now get an updated theory for gravitation, and we've mentioned this before, but let's see what Brian Greene has to summarize.